So today our goal is to find the area under the normal curve, and secondly, to find a value given the area under a normal curve. So you can see here we have our notation. N stands for normal, mu is the mean, and sigma is the standard deviation. So you can see that a normal curve will be single-peaked, bell-shaped, unimodal, and symmetric with the mean at the center. So we're going to look at the first example. When professional golfer Jordan Spieth hits his driver, the distance the ball travels can be modeled by a normal distribution with a mean of 304 and the standard deviation of 8 yards. So these are the 3 tidbits of information that you need to know in order to work this problem. So it says on a specific hole, Jordan would need to hit the ball at least 290 yards to have a clear second shot that avoids a large group of trees. What percent of Spieth's drives travel at least 290 yards? So I'm going to start by putting my mean here. 290 will definitely be to the left of that, and we're looking at least. At least means that's the lowest, so I am going to shade from 290 the curve to the right. So I'm looking at the area under the curve to the right. In order to find out that area or that percent, I'm going to use the z-score formula. The value I am looking at is 290. The mean is 304, and the standard deviation is 8. So that will give me a z-score of negative 1.75. I knew it was going to be negative because it's below the mean. So now I'm going to use my little chart, my table. I'm going to go to the negative side of my table, and I'm going to be looking up negative 1.75. So notice how I have to go over from negative 1.7, and I find the next digit by going up in the chart. So it's the intersection of those two. So 0.0401. So that tells me the area to the left, because the normal table always gives me the percentile ranking, or the area to the left is 0.0401. But we wanted the at least 290 yards. So I want the right side. So I'm going to say 1 minus 0.0401, which is 0.9599. So in order to answer the question, I would say 95.99% of his drives travel at least 290 yards. My next question says, on a specific hole, Jordan would need to hit the ball at most 278 yards to have a clear second shot that avoids a bunker. What percent of Spieth's drives travel at most 278 yards? Now this is a little different. At most means that's the most it can travel. So I am referring to those values that are lower. So I'm going to work this the same way. I'm going to find the z-score, or how many standard deviations below the mean a drive of 278 would be. When I subtract that, 278 minus 304 divided by 8, I get negative 3.25, which doesn't surprise me. It's below the mean. That's why it's negative. So I'm going to go over to the table, look for negative 3.25, and you can see here that the intersection would be 0.0006. So that happens to be the area under the table I'm looking for. So there's no subtracting here. I've got the side I want. So that means my answer is, when I convert that to a percent, 0.06% of the time, he would expect, or he would have a drive of, at most, 278 yards. And then lastly, we've got, on another hole, Spieth has the opportunity to drive the ball into the green if he hits the ball a distance in the top 8% of all his drives. How far does the ball go? So if you'll look with me here, how far does the ball go? We're no longer looking for the area under the curve. We're looking for how many yards would be that particular area. So I'm still going to put the mean. If it's in the top 8%, then that means it's a pretty long drive. So that area is represented by 0.08. So we need to know what that value is that would make that drive so long that it's in the top 8%. So I'm going to start with my z-score formula again. I'm going to fill in what I know. I don't know the value. That's what I'm looking for. I know the mean. I know the standard deviation. I don't know the z-score, but I would like to know how many standard deviations above the mean that was. So I'm going to go to my table. But on my table, I recall that the table only shows me percentile rankings. So if it's the top 8% of his drives, that means that drive would be at the 92nd percentile. So I'm going to go to my table and I'm going to look up 0.92. Now I know that I'm going to be in the positives. 0.92 is a number, 92nd percent, that means you're above the mean. So I can see here, I look for the decimal that is the closest to 0.9200. So that happens to be 9207. So that tells me my z-score would be 1.4 plus 0.01, which is 1.41. So I'm going to put that here. That is 1.41 z-scores above the mean. So in order to undo this equation and solve it, I will multiply both sides by 8. Which is 11.28. Then to undo the subtraction, I'm going to add 304 to both sides to keep my equation balanced. And that means x would have to be 315.28 yards.